Professor Reginald Edwards, and today we will be discussing more math. Now, if you're new to me and these episodes, math stands for, at least in this environment, much awesomeness that helps. Okay, now, moving on. This week is Algebra Chapter 1. We will be basically reviewing and going through different equations and expressions. But first, before getting there, we must first go over some terminology. So let's begin. First, what is a constant? A whole number left on its own. So in this case, also known as a fixed value, a constant in this example is 6x plus 8 equals 20. Now, that's not the constant, this is the equation, but the constant in this equation would be both 8 and 20. So numbers are basically left on their own and not attached to any variables. In other words, it's single. All singly. Okay. Alright. Next one. What is a variable? Now this is a quite a fundamental piece in algebra, because a variable is a letter that stands for a constant or another fixed value. For example, x, and it is standing for 9. But of course this could fluctuate with other situations. Next, what is a zero pair? A duo, so together, the team, the couple, a boo, of a positive and a negative number that then cancel each other out. Now, it could either be a positive number and a negative number of the same value, or like 4 and negative 4, which would cancel out to 0, or it could always be a positive 2 and a negative 9, or like numbers of different values, and there are zero pairs within that then result into leftovers of negative 7. You're essentially subtracting the whole number, or whatever, the lesser number, from the bigger number. And whether that be the negative or the positive, it can fluctuate essentially. So there's that. What is abstraction? Now this one is one of my favorites, I can't lie. To simplify an equation or expression. What this basically means is, for example, whenever you have situations like this, in which, let's just say, y equals 180 plus x divided by 36, instead of doing all this math, you could always just simplify and make your life easier. I don't know, that's what I do. Anyway, so what's something that 180 and 36 have in common? You're just right, 9. So you will divide 9 by both, and then you can get, after that you'll get 20 over 4, and then you can even go as far as to do that again and divide both by 4, in which case you'd be getting 5 plus x over 1 equals y. Next, what is identity? Now, identity is a type of equation in which no matter what value is put in place of that variable, it will always be true. So this basically means, for example, if negative 5x plus 4 is equivalent to 4 combined with a negative 5x, these are both going to equal the same amount, no matter what that x may be. So it could be 1, it could be 2, anything, it will always be equal to each other, be equivalent. Okay, what is a formula? Next one, a factual system to follow by, and it typically has at least 2 variables. Basically, it's a rule, essentially, for different equations and equations. So, for example, this one, 2 multiplied by the sum of 8 plus b plus b plus c equals 50. And then you can plug in whatever numbers find, and really that's just an example. Another one would be the Pythagorean theorem, which is a squared plus b squared equals c squared, and I'll put that at the bottom. Alright, next one. What is a literal equation? An equation that shows a value of a variable. This is one of my personal faves because you don't actually have to do anything for most of the time. In order to get one of these, because all you gotta do is move things around. But for example, one would be x equals d multiplied by r divided by t. And how you can solve this is plugging these numbers into these values. Oh, whoopsie. Good question. See, the thing with that is simply because an equation, which isn't the opposite of an expression, but with an equation, they have equal signs because you're solving something. You're trying to find something out of that problem. Alright, now it's time to get down to the nitty-gritty. Let's roll up our sleeves and put up our thinking caps on. Alright, so first, the equation I've given us, and I'll put it down below, is 7k is equal to 4k plus 15. Now, let's use some algebra trials here and pretend that 7k is, which is a positive number. Let's just say we have, 7 green rectangles, and the rectangles are k. So, and then we have an equal to, so a big line in between them, which is 4k, so 4 green rectangles plus 15. And since 15 is constant, it is left on its own, but let's make that number squares. So we have 15 green squares, 14 green rectangles, and then 7 green rectangles on the other side of the equation. So let's get solving. So first what we need to do is we need to remove this. We need to decide first where we want the variable to be, and since it's easier just to do it here and we don't have to go through more steps, we will move the 4k over to the 7k. So we do that by combining 4 negative rectangles on this side. And then when we do one side, we must do to the other. So combine negative 4 rectangles to the 7 positive rectangles. And then we have 3k, so with that comes 0 pairs. So since this cancelled out, now we have 3k left, which those k's are positive. It's equal to 15. Now we want to get the 3 on its own, so what we'll do is we will divide 3k by 3, 15 by 3. And one way of doing this is by simply, if we have 3 rectangles, and then we take our squares, and then we line those up, matching them, putting them in groups of 3, it will automatically be, an easier way you can just divide, but using the algebra tiles, you would take each k and then line an integer up with it, and then you will find that k is equivalent to 5. Boom. Alright, so that was our first equation, and now let's go on to the next one. Okay, now with less explaining, we'll do another equation. The same, we're going to be adding and subtracting. And with this one, we're going to be doing, first we have 5x minus 2, or combined with negative 2, is equivalent to 3x plus 4. So first we need to decide where we want to put the variable. I say we put it right here. So we need to combine a negative 3x on both sides. And I'll put the algebra tiles below so that I won't have to explain too much of that. And then we have 2x combined with negative 2 is equivalent to 4. Now we can add 2 in order to, we want to add combine its opposite in order to cancel each other out, and now the negative 2 is cancelled out, and then we have 2x is equivalent, and what's 4 plus 2? 6. Got it right. Now what we do is we want to get x alone, so we divide 2 by 2, and then divide 6 by 2, and then we have x equals 3. And then I used the algebra tiles right there while I was explaining that, so those should pop up. And alright, now let's get into some more equations. Alrighty, welcome back. So, now we'll be doing a literal equation instead of our previous linears. But I'll just give a quick example before we get into it. So this is a literal equation, and what we have here is u is equivalent to ak over b. Now we all know that when a number, or when two numbers, or a number and a variable are together, or two variables are together, we know that they are standing for multiplication. So, first, we all know that this fraction is a division problem, so we have to do its opposite, which would be multiplying. So, in order to get this alone, we are solving for a, didn't mention that earlier, sorry, but in order to get this by itself, this equation, we need to multiply b by its reciprocal, which would be b. So, then, what we do to one side, we want to do the other, so we do the same to u, and then we have b times u is equivalent to ak. So, now we need to get a by itself, so we divide ak by k, and divide bu by k. So, then we have a equals bu over k. And there you have it. Alright, now let's get into the real nitty-gritty, shall we? Alrighty, welcome back. Now we'll be using, I think, a similar example to what we used before in the video, but it's a really easy one to explain. So, who will excuse me? Anyways, we have s equals 180n combined with a negative 360. Now, I'm not going to add an algebra tiles just yet, but we can just assume that there are 180 positive rectangles, which are all representing n. But we will include that later whenever we do our abstraction. Okay, so, but I'm getting ahead of myself. Okay. Anyways, first what we want to do is we're going to add 360 on both sides in order for that to cancel each other out. And so we have s plus 360 is equivalent to 180n. And then what we want to do then is we want to divide in order to get n alone, because we're solving for n. We want to, didn't mention that earlier, I'm so sorry. We put 180 down below in order to symbolize that we are dividing. And then we're also going to do the same to this side. So, then we have s plus 360 equals n divided, well, I'm sorry, s plus 360 divided by 180 is equivalent to n. Now, what we need to do in order to get our abstraction, what that is, as I explained earlier, looking at something and being able to simplify it instead of, doing it the hard way. Alright, so what we can do is, what's 360 and 180 have in common? A number. Bing, ba-ding, ba-ding, ding, ding, 9. So, if we divide both of them by 9, then we should have 20 over, 40 over 20. So then we have s plus 40 over 20 equals n. And we can even divide that further by dividing it by 20, which we would then get, s plus 2 over 1, but that's a little too simple if you ask me. And now we get to the final question. Why is it important to have a formula to solve for any variable? And I will use an example. See, the reason is because, let's just say you're measuring a cabinet, and this specific formula helps you find the area or the volume of that cabinet. The numbers, the variables' values will fluctuate depending on what you're measuring or what you're using it for. So it helps us to know a specific formula where we can plug these numbers in and then find what we're looking for. It's very valuable because the numbers will change, but it's important that we have a specific rule to follow by for whenever we know that we'll need to find a certain thing. Alright, now, a good example of this would be volume equals length times width times height. Now, let's just say we have a painting. We have a painting, and its length is 12 inches, its width is 10 inches, and its height is 8 inches. So, it's kind of an oddly shaped painting, I know, but anyways. So, we know that whenever these variables are close together, we will be what? Multiplying, if that is correct. So, let's see, we need to do 12 times 10 times 8. So, 12 times 10, 120. 120 times 8, 260. And within those few steps, we have solved and measured out what we needed in order to find the volume of this painting, which is very important, and that's why we need these formulas. Therefore, we can make the process easier, and also it's kind of fun. You can follow this pattern, and because the numbers may change, and that's why these are so important. Instead of taking these long winding roads of different mathematical uses, you can just have a formula where you can plug stuff in and you get your answer. And so I think that's also really important. And there's tons and tons of examples you can do. You can even make your own and say that m plus r equals t. Really simple. I mean, I don't really know if this would necessarily count as one. This is just basic. But if you were solving for t and trying to figure out t out, and you knew what m plus r was, let's just say m is 5, r is 2, that means t would equal 7. That's just a really simple and easy one. But you can also go further into it and start to do division and multiplication and fractions, which are, are division problems. There's the Pythagorean theorem, which is my faves, which is a squared plus b squared equals c squared. This one, I'm not gonna lie, I find very useful and also kind of fun to do. So, really, that's all there is to it. And thank you so much. Once again, I am Professor Reginald Edwards at Cambridge University. Math stands for much awesomeness that helps. Okay, I'll be back next week. Thank you so much. I hope you really got an understanding of what Algebra 1 really means.